You good to go? Great. Welcome everyone, thanks for attending to this stream. Some quick housekeeping. We're strictly keeping to time constraints here, so if you could please lodge your questions through the app. I'll be moderating those and we'll hit them at the end, or if there's something very pertinent to the time, I'll try actually interrupt these guys and ask the question then. So now we have two speakers from Netscope, Professor David Fairman and Michael Ferguson. They're going to talk about something which aligns quite well to my own advisory approach, which is data-centric approach to zero trust. Thank you, guys.
Great, thank you. Well, welcome everyone. Thanks for coming to hear us speak. Hopefully, our intent is that you walk away from this session and you think about zero trust in a little bit of a different way. I want to dispel some myths about zero trust, and I want to reinforce some very important points about zero trust. So, look, I'm David Fairman. I'm the CSO for APAC for Netscope here. I'm also a partner in a venture capital fund, so I do a lot of work in the startup and innovation community, and I'm an advisor to a number of different boards and startup companies. Prior to my role, or my new chapter, I guess, of my career, I was the Chief Security Officer at NAB, so I ran everything, cyber security, physical security, financial crime for NAB. Prior to that, Group CISO at RBC out of New York and Toronto. Prior to that, ran tech risk globally for JP Morgan out of New York. Prior to that, CISO for RBS in the Americas and EMEA in 2 different roles. I have Michael Ferguson here. I'll let Michael introduce himself.
So my name is Michael Ferguson. I'm the cloud security specialist over at Netscope, been at the company about 4 years, obviously working in that cloud application space, but been in that security vendor land space for about 15 years now, working primarily on web and DLP and cloud projects for large enterprises across Australia and New Zealand.
Thanks, Michael. So look, let's start and discuss what zero trust is. I think personally, everybody in this room and watching at home are probably almost sick to death of the term zero trust. It seems to be used extensively now. I tend to think it's a little bit misused. We think about zero trust in a different way at Netscope. We take a very data-centric view, and for us, zero trust is more than just device or end-user authentication and validation. For us, it's about the ability to continuously assess the context of the session throughout the entirety of the session, taking different data points, assessing them, and taking action at certain points in time based on those changing conditions. There's 2 points I want to make as we dive into this conversation, because I think these 2 points are really, really important in terms of understanding why we think about it this way. First is the network conversion. We know that network traffic has moved out of the data center. We all know that, right? But we've got a very diverse workforce, third-party network environment. And the cloud, the digital transformation has really changed the way that network traffic flows, period. Right? We have remote offices, we have satellite offices, branch offices, we still have our corporate networks, we have mobile users, we have contractors all using their own devices or separate devices. That makes it very hard for us as security practitioners to think about how do we control that flow of data across all those different permutations. There's also the big thing that we can't ignore, which is the data explosion, right? So we know it's predicted that in 2025, we're expected a 3.5x times, or 3.5x increase in the amount of data that we have today, right? It's massive. Through digital transformation, let's talk about digital transformation. Why did organizations progress down the path of digital transformation? They did it for 2 reasons. One, they wanted to automate their business, take the human being out of that process, make it slick and fast and automated. But 2, once they digitized their operations, they had this true value creation asset, data. From that data, they can extract value. They can figure out how do they drive smarter business decisions, how do they operate their business in a smarter way, how do they drive market share and share of wallet, how do they create value for the customer. So that's it. Data today is truly the true value creation of an organization. That's why we really think about why we need to take a data-centric approach to security and zero trust, because that's the asset that we are trying to protect. So with the cloud migration that's happened to support digital transformation, with our data now no longer in the data center and sitting up in these SaaS applications and in these cloud environments, the new attack surface has emerged. We used to try and control data through our endpoints that we manage, through the network that we managed. Those control surfaces have changed, they're gone. Now we have to think about the control surfaces now, the data, the SaaS or the cloud-based applications or services, and the identity itself. So we need to think about each one of them, including the data and understanding the context of that data so we know how well we need to protect it. That's why we have a data classification scheme. That's why in all good security practices, you classify your data. You want it to protect your most important assets. So at Netscope, we think about zero trust in a bit of a different way. The analogy we like to use is the human body, right? So we think of the brain. The brain is about how do we protect that important asset? How do we protect that data? We use the central nervous system to implement the controls or take the actions it needs. So I'll give you an analogy. Think of a person walking along, coming into the kitchen, putting their hand on a hot plate, right? You've been cooking a hot plate. The control or the sensor sends a signal to the brain. Brain goes, ouch, that's really bad, do something. And you move your hand. It's instantaneous, it's in real time, right? That's how we need to start thinking about protecting our important assets. Once you see a change in the environment, once you see that pain at that point in time throughout that transaction, take an action. And if you think about what Tesla did to the way it revolutionized the motor vehicle industry, it's exactly the same thing. We used to build cars with fixed devices, with fixed components, and we used to take them in every 6 months or every 10,000 Ks to get service. We did that so it could optimize its performance, could optimize the experience for the driver, and you could maintain it in a well condition. Well, what Tesla did is it now takes data points from thousands of different data points and different components throughout the running of that vehicle, and it adjusts the experience, it adjusts the performance, and it makes changes to how that car operates at that point in time based on what it's experiencing. Makes sense that we try to do the same thing around protecting our data. Do it at that point in time based on what we're seeing with what we're experiencing. So we spoke about that growth of data, right? We know that organizations are creating data at a pace they can't keep up with getting their hands around it. I've been there with multiple banks trying to roll out data governance programs, data protection programs. How do you really, and we go out and we allocate data owners and we have data custodians and they have to go out and they have to classify their data. We know that's really hard to do, right? It is. And how much of it actually gets done properly? How do you keep it real? It needs to be in real time because that data changes. 1 minute it was an internal only document. Now it's a confidential document. How does that go and get updated, right? So you need to think about that process. How do we do that more efficiently? We can't keep throwing people at the problem, expecting them to be able to maintain this and do that. It's expensive, it's slow, and it doesn't work. We've been there. So what you need a brain that does that for you in an automated fashion. You need a brain that can intercept that data, inspect that data, and automatically classify that for you based on some guardrails and some governance rules that you create. Then, off the back of that, we want to be able to say, now that we understand the criticality of this most important asset, this value creation asset for the organisation, we want to make sure that we control that based on the environment in which it's operating. This is where the Sassy comes in, and Michael's going to talk about Sassy in a minute. For those of you who aren't familiar with Sassy, Sassy is Secure Access Service Edge. And really what Sassy is about, and Michael will do a much better explanation than me, this is about moving the controls that we've normally had within our environment that we've been able to control on those managed devices within the data center, moving those traditional controls, moving them to the cloud. Why do we want to move them to the cloud? We want to move them closer to the data, which is where we know the data is now residing. Makes sense, right? We know that the best defense is to get your controls as close to the asset you need. So we're just doing the same thing. That's what we used to do when it was in the data center. The data was in the data center, our controls were in the data center. So what we need to do is take those controls and move them to the cloud. That's what Sassy is. Context. With the right platform and the right underlying architecture, that right Sassy architecture, you should be able to, if you think about it and implement it correctly, you want to make sure that you've got, a huge amount of visibility. You need to be able to drill into what that user is doing to that data. If you think about cloud applications, and Mike will go into this in a minute, it's really an end user connecting to an application because they want to access that data. And from a SaaS perspective, they're sending commands to that application to manipulate that data. They're doing upload, download, delete. You need to be able to get that level of visibility. You need to be able to understand the instance of that cloud service that you're using. You need to understand the risk of the application. We spoke about that changing control surface. The control surface these days is the data, the identity or the individual, the application, and the data. You want to be able to understand user behavior, not just at the point of time of authentication for the session, but throughout the entirety of the session. What are they doing? Are they doing something that they wouldn't normally do? Is this right amongst, when I compare them to the peer group? What does that look like? Because we know that insider threat is a challenge today. You need to be thinking about how do you build all these requirements, insider threat program is one of those requirements, into this overall architecture. You want to be able to support it from the one platform. You want to be able to understand what that user is doing. I spoke about are they uploading, downloading? Are they transferring, deleting, creating? You want to be able to control what that user does to that data at the command level, right? Not just you can access this application or you can access this instance. You want fine-grained access control. You want to know if a user is going to a production instance of an IaaS application and trying to shut that down and they're not authorized to do that. You want to be able to block that shutdown, that reboot. You want to be able to apply that level of granularity at that point in time. Now remember, when we started, I mentioned the fact that this was a continuous approach throughout the entirety of the session. So the way we think about it, we think of data at the heart. We think about all these sensors and data points which are presented to us through the controls that we deployed. And we look at that continuously throughout that session. We feed all those data points into a risk engine and we apply control dynamically, continuously, adaptively. Michael, I'll hand over to you to talk about the architecture.
Okay, this is what always happens. He creates a problem and asks me to find the solution to it. So the gauntlet's been laid down. We've got the strategy of what we're trying to achieve within Zero Trust. But let's simplify the problem. Ultimately, there's our users connecting to our applications. This has always been the case. We used to build networks and have everything inside the data center so that our users would have continuous connection from the device to their applications, so that they had continuous access to the data, so they could process that data. We needed to make sure that it was remained confidential and its integrity was intact. The problem is that now the applications themselves have evolved so that we have taken some of those applications from inside the data center and moved them up into infrastructure as a service platforms. Containerized, we have some control over it. They could be software that we've developed ourselves, they could be third parties we've installed. They're now inside of AWS or Azure. We've then got some of those applications that are entirely hosted, third parties, the SaaS applications, those that IT have installed, those that the business has started to connect to for the different business areas so that they can gain some of those benefits. In fact, I think it's now about 50% of your applications, I think that's pretty conservative, are now pure SaaS plays, housing your data. Then the users themselves have also changed and are very geographically dispersed. We still have some, despite COVID, working inside of our headquarters, some in branch offices, We've got some of those that are now working outside the network, working from home on managed devices. Some that will be working from home on unmanaged devices, non-SOEs. Then we'll have those that are purely BOD and even contractual users who are connecting to our data. That's important to note. Like, why are these users, these contractors have to connect to our data via the application? So the application is like the gateway to our data. So what we're starting to see is this whole range of communication streams from this wide variety of users to this wide variety of applications. And it becomes very messy, and we're going to lose sight of this. So what we've started to do, and what I've been doing the last 15 years of my career, is going to you and saying, what we need to do is plug this hole in this leaky bucket by giving you a technology that hopefully can deliver a control. We have firewalls in the network so we can get visibility at certain levels. We're going to put in secure web gateway so that we can prevent the web traffic that we don't want. Now we've got our applications are sitting outside, so our users are outside, so we need CASB capabilities that understand what the cloud apps are. But the problem with this distributed set of inspection and policy enforcement points is they're disconnected. You're going to get duplicate policies. You're going to have gaps in those policies, so things are going to continue to be missed. And most importantly, today's point is none of them are communicating with each other effectively. You have to use a third party potentially, and then a human being to go and try and understand where the risk might be, and then try to manually change those policies.
And let me just say one thing. In that environment, what do you do as a security leader, somebody who runs a security function? You build a team of people who are trying to stitch these controls together. Right? Your job as building a security function is taking all these different components. It's a jigsaw puzzle. You take all these components together, figure out how that maps, tie it together with process and skilled people, but it becomes complex and it becomes hard to sync those policies together. It becomes hard to manage and it becomes resource intensive.
So what we need to do is try to simplify this particular problem. I think the easiest way to do this is to create a centralized inspection and policy enforcement point. And we're going to have to do that in the cloud because, as we've said, our data is in the cloud. We've got to put those controls closest to our data. And we're going to stream or steer all of the traffic from all of those users, whether they are in the office, branch, or working from home, or even contractors. All that data has to go through. We're actually kind of fortunate as we've got a good starting point here in the fact that the vast majority of this traffic, this application connectivity, is delivered over the internet. So we've got a control in place. It just has to evolve. The secure web gateway is our connective tissue between our users and the internet. But at the moment, we need it to understand that it's not just websites. I think it's about 85 to 95% of your internet pipe is now being used and consumed to connect to your critical business services.
SaaS services.
The SaaS services.
Applications.
So it's important that we then go, well, it has to understand that this is the CASB has to be involved within that and built in on the same platform. That means it has to have a library of cloud applications so that we can understand what applications my users are accessing and which one carry a higher risk to the organization. Maybe I want to put in place coaching to say that when my users are accessing a riskier application, I'm going to steer them and provide coaching and guardrails to using the sanctioned applications. Maybe they just don't know. There's so much choice out there they need to know.
It needs to understand thousands, tens of thousands of applications.
There are hundreds of thousands of different applications out there, and they continue to be created to create niche capabilities for the different departments in your organizations. They make you competitive, but they are not always built the same. You need to understand where those gaps are. And then secondly, we need to understand the language of these cloud applications. They operate over a different language to the old websites. We do special, interesting things inside these applications. We can move, create, rename. We can approve marketing campaigns in SurveyMonkey and Marketo. We can shut down, reboot servers inside of AWS at the click of a button inside of a browser. That is delivered via the language of APIs and JSON. So this entity, this centralized inspection point has to understand and have visibility over those APIs and JSON. The other problem is that whilst there are hundreds of thousands of different applications, we're all using the same ones. Probably hands up if anyone's using Microsoft Office 365, AWS, or Google Suite. Probably a few of you. So am I, all three. Okay, so that's a problem. If I send a share link to one of your users and say, hey, could you upload these contractual documents to a OneDrive? Okay, it's OneDrive, trust it. No, it's Fergo's OneDrive. It absolutely needs to understand that the different instances of those applications and apply different policy sets to them. So again, understanding that language of APIs and JSON becomes hypercritical on that internet pipe. And of course, because we are transferring data from the user to these applications, having a very strong DLP capability, data protection at its core, allows us to say that we can upload anything we want to our corporate instance of OneDrive or SharePoint or Google Suite. But if somebody uploads tax file numbers, Medicare numbers, intellectual property, we need to be able to apply a multitude of enterprise-grade DLP capabilities immediately to a non-corporate instance. Whether you just have visibility of that or you put in place an enforcement policy to prevent that is really important. And once we've got this entity that is giving visibility across all of these different applications, maybe I want to apply a different application or different controls to, or microservices to this entity. So now I want to use this internet pipe to connect my users to my internal applications, my private applications, using a private access or zero trust private access. Then I want to maybe say, well, I can see all of these different connectivity streams between my users and my applications. Maybe I can start to see all the different weird activities that people are doing. I'm going to apply some user and behavioral analytics to this. I'm going to say, well, if Fergo starts to download 100 files from the corporate instance, then uploads 100 files to his personal Dropbox.
Or attempts to. Or attempts to.
Or attempts to, it gets blocked. I'm really curious about that. And I want to be able to apply scores on those individuals to determine which ones are misbehaving, which ones I maybe need to keep an eye on. And if I'm doing that, why not start to apply some risk-based policies, some adaptive policies to say, well, maybe if a user is behaving poorly, doing those, sharing credentials in Salesforce with a colleague, maybe I want to actually prevent them from then gaining access internally to an internal private application. And I can do this because they're all connected inside this centralized inspection and policy enforcement point. Then I'll just apply additional applications to this engine. I want to say all ports and protocols now. I'm going to do a firewall as a service in this cloud. I want to do remote browser isolation. I'm going to isolate particularly risky websites and applications, and I'm going to have them only be able to execute in an isolated environment because I just don't trust it yet. The risk is too high. So these ones are going to go over there and execute, and I'll just determine whether or not something nasty happens over there and not on my desktop. Then I'm going to have integrated active access via SD-WAN so that those branch offices don't have to send all of that traffic back through their headquarters and then back out via this engine. It can all be streamed to this cloud-based platform directly. And because of this, all these different controls and the connective tissue that we are delivering for our users to our applications, this platform, this engine has to be delivered on the world's largest security private cloud. It has to have data centers globally. Our applications are going to be global. They're going to be stored globally. And our users will start moving around again, or we're going to have offices in different geographical locations, and we can't rely on that public internet to connect us to those services. We are that network now, so we have to be built at scale over high-performance systems with dynamic routing, smart routing, so that we get the best return trip times. And this can now be delivered with a single console, single management console, so that I can do policies in one place for all of those different types of applications. We can be completely agnostic as to whether or not it's SaaS or a private application. I can have centralized reporting so that I can understand what risky applications and behaviors people have been doing across all of these different platforms. And most importantly, you can have a single installation of a single agent, a single client that steers all of this traffic through to this Sassy platform. And by doing that, you're going to see a reducing friction from the business and the adoption of this. We're going to see reduction of costs of implementation, which of course will also continue to reduce risks. So what we're starting to see here is David Fairman's dream of having this central nervous system that is connected to all these different parts of the anatomy of your security ecosystem, whether it's web, it's SaaS applications, the devices that people are on. We're getting the visibility of all of this. We're generating a lot of analytical information and data that that allows us to maybe start to put in place some continuous assessment and automation of those policies. And I actually think we can start to go a little further than this by taking in third-party information. I want to look at the other elements of the ecosystem that maybe that the Sassy doesn't deal with, and I'd say, well, maybe I take in the telemetry from an email security engine. I want to know if somebody's been targeted with more malware or has failed security, the security awareness training that we get on the phishing education that we deliver via email. And if that happens, maybe I don't trust that user to be able to upload files anymore. Maybe from an identity perspective, I've seen multiple failed logins. I've seen geo irregularities. Again, it contributes to the risk of the individual at that point of the transaction. I want to know what's happening here. From an endpoint perspective, it could be an unmanaged OS. Do I trust that device to download files? There's certain things that we can gain if we're all communicating these different areas to a singleized inspection and policy enforcement point. So I think that's what we're starting to deliver on here. Similar to that the Tesla analogy is saying, well, if I've got sensors in each part of my anatomy, in each part of this ecosystem, I can feed that telemetry to ensure that when the tread comes off the tires, I can no longer go into sport mode. I'm maintaining the ability for my users to get to where they need to safely and securely. And this is what it would look like. So basically, from every single inline inspection transaction, we're going to continuously evaluate all of those different parts of the transaction, all that contextual information. Is the data sensitive or not? Is the identity valid? Is the application of a certain risk to my organization? Is the endpoint patched and safe and secure? And there's the previous behavior being good. And what networks are they coming from? Are they inside the network? Are they outside? And all this information itself runs through a particular a risk engine to give us context as to whether or not that particular transaction is risky and should be permitted, denied, restricted from doing what they were trying to do. And all that information can then be fed back into the next inspection, the next transaction, to gain greater context. And again, if we put more telemetry into this, then we can hopefully start to gain richer understanding of the risk from those third parties as well.
So Michael, I want to dig into application risk for a minute. You talk about building in, understanding the application risk. You want to explain a little bit about what that means and how that's determined?
So from Netscope's perspective, we have a huge library of SaaS applications that's just built into the platform. Every time that you go to a particular application, drive.google.com, we're going to know, okay, that's Google Drive. Super easy. But we are trying to provide you with a quick, easy risk assessment of those applications to hand. When what we do with that is we assess these applications regularly. I think it's every month that we're able to do this.
We do a new release every month. Well, yeah, new release every month of updated apps.
And we give it a quantifiable risk score 1 out of 100. And you can set a benchmark if you wanted to and say, okay, anything below 60, high risk, I'm going to coach my users away. They can still do it, but try and provide those guardrails. But how we get to that point, how we get to the understanding of where the risk might be, is we assess them using the Cloud Security Alliance's Cloud Controls Metrics as a framework. There are a few other bits and pieces like vulnerabilities and breaches that may have occurred. But what that means is that we are providing you with the information to say, what standards does that application adhere to? From a compliance perspective, does it hit PCI DSS standards? Does it hit HIPAA? And based on your organization, that might be really important to you. But we can go above and beyond. I think there's about 27-ish different categories within that CCI assessment that we do for every application inside of our library. And the library is about 41,000 different applications at this point. It's always growing as the ecosystem grows. And we assess them against each one of these. And it could be data protection. Does it encrypt the data at rest, in transit? Does it segregate the data? Does it do backups? Started my career taking backup tapes out, giving them to Iron Mountain. Now you look at how many applications don't back up their data. Some don't need to, but I'd like to know. It's really important to understand where the risk might be in these SaaS applications that marketing and HR and finance and all the other areas of the business are signing up to. So having that library of assessing the risk of an application becomes hypercritical. And to deliver this as part of that zero trust ecosystem and engine to protect the data in each transaction, very, very powerful.
So let me just take a minute to talk about that, because I think that's really, really important, right? So we're not just with Sassy seeing the convergence of network and security teams come together, because clearly that's evident by the Sassy platform, right? There's a security element, there's a network performance element to that. But what you've just said about the application risk element and giving you very regular updates, and the fact that we continually monitor those SaaS applications, we've got 40-odd thousand, whatever it is, applications in our library. Who's trying to stand up a third-party risk assessment process to manage supply chain risk, right? Extremely, extremely difficult. You'll go out and assess those suppliers once a year if you're lucky. You're probably doing a risk-based approach. You're going to look at the top 100 vendors if you're lucky, and then what are you doing about the rest? How do you go, and you're probably looking at the controls in those vendors, and then you're trying to figure out, do we even going to go and look at the application itself? Think about how this platform helps you step change your procurement supply chain risk process. Now this is bigger than just a security discussion. This is a supply governance and procurement discussion, right? And how can you help them build out their program? Pretty important point.
So let's try and look at some of these examples of what this might actually look like in the real world. So scenario one, okay, I've got a couple of remote workers, might be quite familiar for some of you, working from home, but they're accessing the same application. The difference is, so the same IP address, the same host name, that's what they use to connect. It's an internal application that's been developed in-house. Now, the users are different as well. They're different roles. One is a user that has to operate and work on the application, just part of the daily process, and the other one's a developer. So the developer has to have additional levels of access. It needs to be able to access it from different ports to be able to get into the back end, SSH, and do some different controls and activities within the application. So at the point of transaction, I need to be able to understand what the user, who the user is, where the destination is, what devices they're on, where they're coming from, and maybe how they're trying to access it, the different ports, to apply different controls to say that if the day-to-day user tries to access it via SSH, they're not allowed to. If the developer tries to access it, maybe they're allowed to, but if they're outside the network, maybe they're going to get a prompt via their identity provider to re-authenticate. Because they need to re-authenticate if they're going to start messing around from outside of my network on my applications. So it's the context of each individual point in that action to determine what the outcome will be. Scenario two, again, we've got two users accessing the same application and uploading the same document. Document that contains employment forms. It's a folder they're trying to upload to their new cloud storage. So the application's the same, it's going to be OneDrive. The difference is that one of those users logs into OneDrive with their corporate account, the other one logs in with their personal account. They try to upload the same file. We need to see all the different steps in that transaction, all the different pieces to determine whether or not they should be allowed to upload that data to a corporate or a personal instance. And obviously, hopefully, the upload of those documents to the personal instance will be blocked.
But couldn't you just block that through the URL?
Well, some of these applications, the URL isn't completely the same. You know, you can go to aws.amazon.com for every single one of you. You know, drive.google.com, SurveyMonkey. All these applications, the URL can deliver you to the same application. It is the API and the JSON strings inside of that communication, that connection, that allows this Sassy entity, hopefully, to be able to determine what the instance is. And if I know the instance, I know what the potential risk might be in comparing a corporate to a personal, to a third-party reseller, professional service integrators. All these guys have got using the same applications, accessed by the same URL, but that API will be different. And that's what we need to understand. Scenario three. Now, if we've got users going to that huge ecosystem of cloud applications that are available to them, as long as they've got an internet connection, we need to be able to determine what the risk might be to those applications. So if my user is uploading to a cloud storage application, uploading a document that is hypersensitive, as I say, we need to be able to determine what the risk might be of that application, using that library of cloud applications, using that quantifiable risk score potentially, or even individual components of that library, of that assessment, to say if the application is of a higher risk, I'm going to put in place a block or even maybe just a coaching page, a guardrail to say, hey, did you know we have a sanctioned version of cloud storage that is available? Please use your OneDrive, use your G Drive to perform this transaction.
So now it's complementing to your training and awareness program.
Exactly. Inline continuous education around the risk of cloud applications and this landscape that is occurring. And what's kind of great about this scenario is we can put in place reports to say, let's look at the last month of uploads to risky cloud applications. And hopefully, if we've got this educational coaching page in place, we can start to see every day the fall of bytes uploaded to those risky applications because they're starting to become aware that there is an alternative out there.
Okay, well, look, hopefully that was enlightening, informative. That's how we're thinking about Zero Trust. We don't see Zero Trust as a product, as a vendor solution. We see it as a framework that's part of an entire ecosystem. That's why you need to understand some of those actions, what's happening on the endpoint, understanding some of the email elements. Look, that's our story. This is where we're taking our platform. Would love to talk to any of you about it in greater detail. Please contact us at cso@netscope.com if you have any questions. Thank you very much. Any questions?
This one on? Yep, great. So, first question, Richard asks, with the world's largest private cloud providing the underlying infrastructure for this, how much would the running cost be purely from a technology perspective for a typical org use case?
That's a really tough question because I'd need to understand the size of the organization, number of users, et cetera, et cetera. Michael, do you want to have a crack at that?
Yeah, don't talk dollars with this one. No, so ultimately the way that Netscope operates is a subscription basis. That platform, the architecture that we put our services onto, it just has to be a running cost to us. Like, it's just part of it. It's not like I can charge you to have this wonderfully peered network. It's a subscription basis based on the number of users and those individual security outcomes that you're trying to get out of it, whether it's different microservices that you're looking to get out of it. And that what's great about that is that once you're connected to this huge cloud architecture of ours with those initial services that you're after, once you start to go down that road, you can go, well, maybe next month I want to have a different service as well. I want to add on different capabilities to it. You're already installed and running with the service.
Do you want to, you touched on a point there around the peering. Do you want to talk about how paired we are?
Yeah, so what's kind of interesting is that if we're being this network as a service and your applications are hosted in all these different MSPs, Microsoft data centers, AWS, it becomes really important that this service that we're delivering is connected to those applications directly and paired with them directly and hosted locally in the same locations as those, so that you are never having to rely on the public internet to get your user to your data. Instead, you hit the Netscope infrastructure, and using our dynamic routing, we can get you to wherever those applications are. And through our peering, we're able to get you to a direct handover to your data. And Netscope is now actually the 6th most peered cloud network globally. I don't mean cloud security. Network is like Netflix, Facebook, Amazon, and Netscope. And that's huge for delivering you the best connectivity and round trip time for access to your data and your applications.
Cool. Matthew asks, how does the structure of an organization need to change to support this very different security model?
Great question.
With a sort of lead on from that, who's typically responsible for maintaining the implemented policies once you've changed?
Yeah, look, I get asked that question a lot, and I think every organization is different. I touched on the point that we're seeing a convergence of network and security teams as a result of the cloud transformation and digital transformation that we're seeing. Sassy is bringing that to life. I can't tell you what the best model is. I think it's very different on each organisation, and it will depend on the operating model defined within that organisation. Some security teams take on the role of the policy and governor versus the operator of the controls. Some network teams are the operators of the controls, and they're needing to meet the expectations of the security teams. In other organisations, security teams are defining the expectations and the standards, and they're operating their own controls. I've worked in organisations with varying different operating models. I think it's a journey for organisations. Typically what we are seeing ultimately is that The network teams are sort of implementing the network infrastructure, but the security teams are still operating those controls, those services. So the network teams will own the underlying infrastructure, but the security teams are defining the policies, controlling the policies. Remember, it's a single policy enforcement point that's pushing onto that core. So we see that a lot, but we are starting to see a convergence of those network and security teams. In fact, we've made the prediction that in 5 years' time, the traditional security execution teams will converge with network security teams.
Cool. So I think we may have already cut off with the stream, but we might still be good. So thank you very much, gents. There's a couple more questions that I'd actually posted, but I'll take them up with you separately.
Perfect.
Thank you very much.
Thank you, everyone.
Thank you very much.
Mate, thank you. That's good.
I wanna play while I